For decades, it was the ultimate scientific punchline that fusion power is always 30 years away. But in the year 2026, the laughter has stopped and the lights of a new civilization have been switched on. The era of fossil fuels and the shadow of carbon emissions are finally receding into the history books. We are witnessing the dawn of the artificial sun, a breakthrough that promises infinite clean energy for every human being on Earth. Imagine a world where electricity is so cheap it is no longer metered, and where the very air we breathe begins to heal. This is not a dream of the distant future, but a reality being forged inside massive steel chambers and magnetic cages. Welcome to the heart of the star, right here on the surface of our planet. The journey to this moment began with a simple but profound observation of the night sky. Every star in the universe is a massive nuclear fusion reactor crushing atoms together to create light and heat. For a century, the greatest minds in physics have tried to bottle that celestial fire inside a laboratory. The challenge was monumental because the center of the sun is a place of extreme pressure and unimaginable heat. To recreate those conditions, scientists had to build the most complex machines ever conceived by the human mind. The primary weapon in this battle for energy is the Tokamak, a donut-shaped vacuum chamber designed to hold a star. Inside this stainless steel vessel, hydrogen isotopes are heated until they become a swirling purple plasma. This plasma is hotter than the core of the actual sun, reaching temperatures of over 150 million degrees Celsius. No physical material on Earth can touch this substance without vaporizing instantly into gas. The solution was to create a magnetic cage using massive superconducting magnets cooled to near absolute zero. These niobium tin coils generate magnetic fields hundreds of thousands of times stronger than the magnetic field of the Earth. They suspend the glowing plasma in midair, preventing it from touching the walls of the reactor. The engineering required to manage a temperature difference of millions of degrees across just a few meters of space is staggering. In 2026, the International Thermonuclear Experimental Reactor, or ITER, reached a historic milestone known as ignition. For the first time in history, a fusion reactor produced more energy than it took to start the reaction. This net energy gain is the holy grail of physics and the key to a sustainable future for humanity. The fuel for this incredible process is found in the very oceans that cover our world. Deuterium, a stable isotope of hydrogen, is extracted from ordinary seawater in a simple filtration process. Tritium, the second part of the fuel mix, is bred inside the reactor itself using the metal lithium. A single bathtub of seawater and the lithium from 2 laptop batteries could power a human life for 30 years. There is enough fusion fuel in the Earth's oceans to power our civilization for millions of years to come. Unlike traditional nuclear power plants, fusion creates no long-lived radioactive waste and carries zero risk of a meltdown. If the magnetic cage fails, the plasma simply cools down and the reaction stops in a fraction of a second. It is the ultimate fail-safe technology, providing the safety that the public has long demanded from nuclear science. The economic implications of this breakthrough are sending shockwaves through the global financial markets. Oil rigs in the Gulf of Mexico are being decommissioned and transformed into research stations and marine sanctuaries. The heavy hum of coal-fired power plants is being replaced by the silent efficiency of fusion facilities. Developing nations are now looking at a future where energy poverty is a thing of the past. With infinite energy, we can power massive desalination plants to turn salt water into fresh water for thirsty cities. The greening of the Sahara Desert and the restoration of the Aral Sea are no longer impossible fantasies. Vertical farms lit by artificial suns can grow fresh vegetables in the middle of the most crowded urban centers. The cost of transportation is plummeting as electric cargo ships and high-speed maglev trains run on fusion power. Even our atmosphere is beginning to change as we use excess energy to scrub carbon dioxide directly from the air. Giant carbon capture fans are being built alongside fusion reactors to heal the damage of the last 2 centuries. The blue skies of our cities are returning as the smog of the internal combustion engine vanishes forever. But the reach of the artificial sun extends far beyond the atmosphere of the Earth. Fusion is the key that will unlock the solar system for human exploration and colonization. Current chemical rockets are too slow and inefficient to carry humans to Mars in a reasonable amount of time. A fusion-powered rocket engine could cut the travel time to the red planet from months to just a few weeks. The vast distances of the outer solar system, like the moons of Jupiter and Saturn, are finally within our grasp. We're no longer a species confined to a single rock, but a spacefaring civilization fueled by the power of the stars. The control rooms of 2026 are filled with a new generation of scientists who grew up with the hope of this discovery. They monitor holographic displays and neural networks that manage the delicate balance of the plasma fire. The sound of the cooling pumps and the hum of the power grid is the heartbeat of a world reborn.